The last video explained what problem the new data model is solving, and now this video is going to show you how you can build a new data model. So let's start by connecting to these CSV files, so specifically the donations CSV files. And you'll note that the UI is a little bit different here. It's automatically connected to that donations table, and now we can link the other objects to it. So I'll just double click on donors. Note that we haven't yet implemented drag and drop, so just be mindful of that in the current alpha build. And so we'll link those two on the donor IDs, and Tableau's doing some helpful things like telling you you can't link a string to a number here. And then if you want to roll this up and add another one, you just select the heading. Now, this is a very early design, and what we ultimately release will probably look quite different to this, but it's just to explain how it works in the current alpha. Okay, so now when you want to add the next table, make sure that you have selected in the graph the object that you want to link it to. So I want to link projects to donations, so donation is selected. I'll double click on projects and then go and link this on project ID. Apply and close. Now I want to link schools to projects, so I have to select projects in the graph and then double click on schools, and it's going to prompt you to relate these on school ID as well. So I'll just go and hit apply and close, and then finally we want to link teachers to projects as well. So double click on teachers and then go and link these on teacher ID and close. All right, so a couple of things that are sort of substantial changes versus the existing version 2018.3 is that now we haven't actually defined any joins. Right, so in the legacy or kind of existing version of Tableau, you have to specify, is it a left join, is it a right join, because it uses that to then join all tables all the time in a single flat table. Here we're just defining relationships, which you can think of relationships as like as a contract, and then think of joins as like an execution of that contract. So rather than executing all the joins up front, Tableau will decide on the fly, on a sheet-by-sheet basis, which joins type to use based on the fields that you bring in from one object or a combination of different objects. So that's one major difference. And then the other major difference is that we no longer have a single flat table in the data grid. As you click around here, you'll notice that there's actually a separate table for each of these objects. So there's also implications for how this data gets stored, because if we were to extract this, then what will happen is, which I would recommend doing on CSV files for performance reasons. So what happens if you extract this is it extracts a single table per object. So there will be 5 tables in the extract underpinning this data model. And in some cases, that can give you substantial performance improvements, particularly when you're filtering down to a small result set, because rather than materializing your joins, you're filtering first and then joining on the small result set. So that's another. There's major performance benefits to the new data model. All right, so let's go ahead and just go to sheet 1. Now recall from the last video that when we connected to the projects, I'm going to just switch to the extracted version here just so it's faster than the CSV version. So when we had connected in the last video to a single project table, the project cost was 4.3 million. So we want to make sure that that is the number that we're seeing. So let me go and grab the project cost and drag that into here. And now you'll see that we are getting the right number for the project cost, despite the fact that this project table is integrated in a much richer data model than just its own table. So that's one of the huge advantages of the new data model, is that Tableau will only include the required tables in the join as opposed to joining everything. So you no longer need to write all of these crazy level of detail expressions to readjust your measures. You don't need to always be doing full outer joins and then having to deal with nulls caused from data that doesn't exist in one table that you may not care about in the context of your analysis here. So we're automatically getting the right number here. And another nice feature of the query semantics of the new data model is that it will display full domains. So, for example, if you have schools that don't have any projects, so if I grab the school name and then look at the associated project cost, if we go and let's just look at it this way, you'll notice that there's a number of schools that don't have any projects. And so we're still displaying the full domain of those schools even though there's no associated projects. And if you wanted to remove them, rather than going in your data model and saying, oh, make this an inner join, we can just simply filter that out by saying, remove the schools where the project cost is, or rather keep the ones where the project cost is positive, and now it's removed and effectively done an inner join, but that inner join is applied through filtering. So it's a much simpler way of essentially deferring a data modeling decision into analysis time. So just in summary, there's huge performance gains because of resulting from normalized extracts and from aggressive join culling, which means we will only use the tables required in the join. You automatically get the correct measure aggregations, and then there's also some intelligence around displaying full domains, which defers decisions like joining into analysis, whereby you simply apply filters to specify which records to keep or not keep from different tables.